To talk about back titration again, and this time round we are using a question to illustrate everything. Just like I told you in the definition of back titration, the analyte is reacted with an excess of one of the solutions, and then the excess solution is titrated against another solution. And remember, the solutions in this case must be standard solution. Okay? Looking at this question, we have 50 cubic centimeters of 0.2 molar HCl. That means this solution is a standard solution. It's added from the burette, so it is the titrant. Okay? To 0.8 grams of limestone, and the flask was gently swirled until the sample had reacted completely. So there is a reaction between HCl and limestone. Okay? In this case, what is in limestone is calcium carbonate. There is a reaction. Once that reaction has, okay, let me label this as first reaction takes place here. Are you following? Yes. Then excess of this, because this is a standard solution, excess of HCl is titrated with another solution. In this case, the solution in question is potassium hydroxide. And you realize it is also standard because the concentration is 0.1 moles per liter. This is the second reaction. Second reaction. So here we know the concentration of this, but we don't know the concentration of this. Okay? Yes. So in this case, this one is analyte. Okay? Then we use excess of this one to react with another substance. From the equation, we know the concentration of this one being 0.2 moles per liter. The concentration of this one being 0.1 moles per liter. So I've always told you that whenever you're given a question like this, you begin from known towards unknown. Are we together? Yes. You begin from known information to establish the unknown information. Huh? Right? So let us begin from here and go backwards. The moles, let me arrange them this way. Moles of, they are saying that excess hydrochloric acid, so excess, they have not specified which volume, okay? Yes. Of hydrochloric acid was titrated with 36 cubic centimeters of 0.1. So at least here we know volume and we know concentration for potassium hydroxide. So let us begin with potassium hydroxide. Why are we beginning with potassium hydroxide? Because we know both variables, volume and molarity. So moles of potassium hydroxide used. Let us get here. 0.1 capital M means molarity. That is 0.1 moles are in 1 liter. But the volume was used. The volume used was 36 cubic centimeters. Just do simple cross multiplication here. That is 36 times 0.1 divided by 1000. That one gives you 0.0036 moles. These are the moles of the base that were used. Metal hydroxides usually are bases. Now, how are we going to get the moles of excess HCl that were reacted with potassium hydroxide? We use a balanced equation. Moles of HCl, of excess HCl. Let us be specific. So we write an equation, potassium hydroxide solution reacting with hydrochloric acid solution. Acid and base gives a salt. So this salt is going to be potassium chloride. It is also still in solution. Then we are going to have water. You get mole ratio from there. And ensure the equation is balanced. Is it balanced? Confirm the number of each atoms on the left and on the right. You realize they are balanced, isn't it? Yes. So meaning mole ratio. We have 1 mole of potassium hydroxide reacting, 1 mole of HCl reacting, isn't it? Yes. And then here we go to the moles of potassium hydroxide. Place them here under potassium hydroxide. Find the corresponding moles for HCl. Just simple cross multiplication. 0.0036 times 1 divided by 1. The mole ratio is 1 to 1, meaning you just get the same value. These are the moles of excess acid that were reacted with. With what? Potassium hydroxide. Now, let us go back here. They are saying 50 cubic centimeters of 0.2 molar HCl were added from the grate to this. What do you understand from them? Do you know the volume that these moles represent? How are we going to get that volume? We know that the concentration of HCl is 0.2 moles per liter, isn't it? So let us find the volume of excess HCl used. The concentration is 0.2 moles per liter. Per liter. Isn't it? What about the volume that was used? 0.036. The volume that reacted with potassium hydroxide. Okay? So that is 0.0036 times 1000 divided by 0.2. That gives 18 cubic centimeters. This is the volume reacted with potassium hydroxide here. You understand?